Okay, this is video 2 on the photoelectric effect. Just want to finish what I started with. So the energy that the photon gives to the metal is used first for the work function, so to eject the electrons, and then what's left is used for kinetic energy to move the electrons. Okay, so the difference between the energy of the photon and the work function of the metal, the more energy is left for the kinetic energy. In other words, the faster the electron will move. So then, if we put the metal there and we connect it to a circuit, we call this a photocell. That is going to provide current to this circuit. So we can, we're going to need a light source, we're going to need a metal with a certain work function, and then we can connect either an ammeter that would measure the current, or we could connect a light bulb that would become brighter the higher the current would be. Right. So we could do two things to this light source. We could either change the frequency. So you remember, that means we can change what type of electromagnetic radiation we have, whether we have ultraviolet or infrared or X-rays or gamma rays or microwaves or visible, one of the visible frequencies, red, orange, yellow, green, blue, indigo, or violet. So we can change the frequency, and then we can predict what the changes would be, or we can change the intensity of the light. So the intensity is basically how bright this is. So it's the difference between a candle and a 5-watt light bulb, or a 14-watt light bulb, or an 18-watt light bulb. So that's the intensity. So if we think about frequency first, if we change the frequency, because energy is H times F, if we increase the frequency, we're going to increase the energy, right? And the energy, you remember, is used for the work function to eject the electron, plus kinetic energy. So this stays constant. The metal doesn't change, so the work function stays the same. So it's going to use the same amount of energy for the work function. So if we have more energy, it's going to use the same amount of energy for the work function, and more energy is left for the kinetic energy. So eventually we have a higher kinetic energy. Higher kinetic energy because kinetic energy is half mv squared, and the mass of an electron stays constant. It's going to increase the velocity of the electron, that photoelectron. So the electron will move faster. So you'll have one that's released, and instead of going through the ammeter slowly, it will move through the ammeter quickly. Okay, so the electrons are faster. There's not more of them, not more, just faster electrons. So the current would stay equal, because the current is the amount of electrons that pass this point in a certain time. Okay, so you remember from circuits, we said the brighter, the higher the current, the brighter the light bulb. The lower the current, the less bright the light bulb. So because the current will stay the same, the brightness of a light bulb will stay the same if we change the frequency. Okay. The only thing that will happen is if the frequency is now lower, if we decrease it and the frequency becomes lower than the work function of the metal, then current will stop flowing, right? So then they will get a 0 reading and that light bulb will not shine anymore. Or if we have a higher frequency, the current will still measure the same, the light bulb will still measure the same, but the electrons will just move past this point faster. But the same amount will pass in a certain time. There will just be more pauses in between. Okay, then the change in intensity. So if we basically make it brighter, if we increase the intensity, we make the light source brighter. All right? So what that means is instead of, let's say, 1 photon reaching that metal, we have, let's say, 3 or 4 photons. It's actually millions at a time, but for simplification, when we increase the intensity, we are increasing the amount of photons that reach this metal. Now, each 1 photon releases 1 photoelectron. So if we increase the intensity, we make it brighter. We increase the amount of photons that reach the metal, and therefore we increase the amount of photoelectrons that will be ejected. Okay? So now, because there's now 4 photoelectrons ejected instead of just 1, now we have more electrons that are released, more electrons pass the ammeter in a certain time, which means current is now increased. If it wasn't an ammeter, it was a light bulb. Because the current increases, we have a brighter light bulb. Okay, so the energy stays the same. They are still this moving at the same kinetic energy, but there's more of them that pass that point in a certain time, so the current is increased. Okay, that's everything for the photoelectric effect.